Okay, so substitution method of solving simultaneous equation. In this method, it involves basically substitution. What is substitution? Replacing one value with another value. So what happens is, if you have two equations to be solved simultaneously, then you are going to make one variable the subject of the formula in one of the equations and substitute it into the second equation. Let's look at an example. Okay, so we are solving these two simultaneous equations. So first we need to identify them. Let's call this equation 1 and let's call this equation 2. The next thing we do is we make one of the two variables the subject of the formula in either of the two equations. What do I mean? If you have learned about subject of the formula, what you're expected to do is, if you are making x the subject of the formula, then x has to be alone on the left, while every other value on the left is to be moved to the right. Okay, so if you can make x the subject of the formula in equation 1, you can decide to make y the subject of the formula in equation 1. Also, you can make x the subject of the formula in equation 2, or you can make y the subject of the formula in equation 2. So whichever one you want to make the subject of the formula, you are correct. But the only rule is, if you make any of these two variables subject of the formula in equation 1, you have to substitute into equation 2. If you start with equation 2, you have to substitute into equation 1. So you cannot start with equation 1 and substitute back into equation 1. You cannot start with equation 2 and substitute back into equation 2. So that's a very important rule. So let's see. So for this particular example, let's make y the subject of equation 1. Let's make y the subject of equation 1. So I want to make y the subject of equation 1. Equation 1 is 3x plus 2y is equal to 7. So making y the subject of equation 1 means y is going to be found alone on the left. This means 3x has to be moved to the right, and 2 also has to move to the right. So we start by moving 3x to the right. When 3x moves to the right, it becomes minus 3x. So we're going to have 2y is equal to 7 minus 3x. So we have moved 3x to the right. Next, we need to eliminate 2 from the left. We do that by dividing both sides by 2. So 2 is going to cancel out 2. We have y is equal to 7 minus 3x all over 2. So at this point, since y is alone on the left, we have made y the subject of the formula. So we can call this equation 3. So we have made y the subject of the formula for equation 1. We started with equation 1, therefore, when we want to substitute, we are going to substitute into equation 2. So we are going to substitute y in equation 3. We are going to substitute y in equation 3 into equation 2. So what does this mean? Substituting y in equation 3 into equation 2 means wherever I see y in equation 2, I'm going to replace it with 7 minus 3x all over 2. Because y is equal to 7 minus 3x all over 2. So we have 5x minus 3. So this is supposed to be y, but I'm going to replace it with 7 minus 3x all over 2 is equal to 37. Okay? So we're supposed to have y here, but we have replaced it with 7 minus 3x all over 2 because y is equal to 7 minus 3x all over 2. So I can easily replace it. Now I need to expand this. So how do I expand this? We've learned about, not in this particular class, but in a previous lesson, I've taught how to solve equations containing fraction and bracket, containing a fraction and a bracket. So all you need to do is multiply the entire equation by 2. So once you multiply the entire equation by 2, this 2 is going to cancel out. Okay? So we multiply the entire equation by 2. So what does that mean? 5x multiplied by 2 will give us 10x minus 3 bracket 7 minus 3x all over 2. When you multiply by 2, these 2 will cancel out these 2. So you're going to be left with minus 3 bracket 7 minus 3x. Because these 2 will cancel out with these 2. Is equal to 37 multiplied by 2 is going to give us 74. So with this process, you've canceled out these 2 here. So now we can have 10x minus 3 multiplied by 7 gives us minus 21. Minus 3 multiplied by minus 3x gives us plus 9x is equal to 74. Now we pick these two like terms together. 10x plus 9x gives us 19x minus 21 is equal to 74. So we move minus 21 to the right, it becomes plus 21. So moving minus 21 to the right, it becomes plus 21. So we have 19x is equal to 74 plus 21. 19x is equal to 74 plus 21 is 95. 95. So next, we divide both sides by 19. When you divide both sides by 19, what are you going to get? So 19x all over 19 is equal to 95 all over 19. X will be equal to what? X is equal to 5. So now we've gotten the value of x to be equal to 5. So we've gotten the value of x, but we need to find the value of y. Remember, solving simultaneous equations means finding the value of the variables. We've gotten the value of this variable. We need to find the value of this variable. But we know that from what we got in equation 3, y is equal to 7 minus 3x all over 2. That's what we got. Y is equal to 7 minus 3x all over 2. So now we know the value of x to be equal to 5. So where we have x here, we can replace it with 5. So this gives us 7 minus 3 bracket 5 all over 2. So I'm still going to wipe this side off. Y is equal to 7 minus 15 all over 2. 3 multiplied by 5 gives us 15. So we have minus 8 all over 2, which gives us minus 4. So the final answer is x is equal to 5 and y is equal to minus 4. So we are not sure if that is the answer. We are not sure if that is the answer until we put our values back into the two equations. If the left and the right sides are equal for both equations, then our answer is correct. So x is equal to 5, y is equal to minus 4. So let's put it back into the first equation. X is equal to 5. 5 times 3 gives us 15. So we have 15 here. Y is equal to minus 4. Minus 4 multiplied by 2 gives you minus 8. So 15 minus 8 gives us 7. So that shows that our answer is correct for equation 1. So we have to do the same thing for equation 2. So putting it in equation 2, x is equal to 5, we have 25 So here is 25 minus 3y. Minus 3 times minus 4 will give you plus 12. Because minus multiplied by this minus will give you plus, and 3 multiplied by 4 will give you 12. So 25 plus 12 will give you 27. So that shows that these answers are accurate for both equations. So if you solve the equation and your answer is correct for one equation, but not correct for the other equation, that shows that your answer might not be correct. Okay? For it to be correct, it has to be accurate for both equations. Both equations. So we've solved the first equation. We're going to look at a second equation. Let's look at the second equation. So here we're expected to solve for x and y in x plus 2y is equal to minus 4, 2x plus 5y is equal to 1. So when you have a situation like this, when one of the variables have a coefficient of 1, if you observe here, x has a coefficient of 1. So once you see any variable that has a coefficient of 1 and you're solving using the substitution method, always make this variable the subject of the formula. Okay, so we are going to make x the subject of the formula. It makes your work easier. If you make this the subject of the formula, it makes your work complicated. You're not going to get the wrong answer, but it just gives you more work than you should have gotten if you started with this one. Okay, so it's just a way out. When you see a variable that has a coefficient of 1, always make that the subject of the formula. So make x subject of equation 1. So we make x the subject of equation 1. So equation 1 is x plus 2y is equal to minus 4. So when you move plus 2y to the right, this is equation 1, this is equation 2. So when you move plus 2y to the right, it becomes minus 2y. So we have x is equal to minus 4 minus 2y. So let's call this equation 3. So because we've made x the subject of the formula already, x is alone on the left. Therefore, it is the subject of the formula. So next, we substitute this value of x into equation 2. Remember, we started with equation 1. Therefore, we substitute into equation 2. So substitute x into equation 2. So this means wherever I see x in equation 2, I'm going to replace it with minus 4 minus 2y. So this will be 2. Now there's x here, but I'm replacing it with this. Minus 4 minus 2y plus 5y is equal to 1. Next, 2 multiplied by minus 4 will give us minus 8. 2 multiplied by minus 2y is going to give us minus 4y plus 5y is equal to 1. So minus 4y plus 5y will give us y. So we have minus 8 plus y is equal to 1. So if we move minus 8 to the right, it becomes plus 8. We have y is equal to 1 plus 8. Therefore, y is equal to 9. So now we've gotten the value of y. We can now go back to equation 3 that says x is equal to minus 4 minus 2y. And then wherever we see y, we are going to put 9. Wherever we see y here, we are going to put 9. So x is equal to minus 4 minus 2y. So we're going to replace y with 9. So x is equal to minus 4 minus 2 into 9. Minus 2 times 9 will give us minus 18. So x is equal to minus 4 minus 18. X is equal to minus 22. So that is the value of x. That is the value of x, minus 22. So now we've gotten the values of x and y. Therefore, we can say x is equal to minus 22 and y is equal to 9. So these are the solutions to this simultaneous equation. So try out this question.